This is an introduction and training to using the laser cutter in the Innovation Gym. The laser cutter is a powerful tool that can be used for making parts and very quick prototypes through cutting or engraving many different materials, including wood, plastic, paper, etc. The laser cutter is a CNC machine, or a computer numerical control machine, which basically means that the computer tells the laser how to move and respond. The laser itself is good for cutting, which for the rest of this presentation we will call vectoring, or engraving, which we will call rastering. The input file for engraving is a bitmap file, such as a JPEG or a picture, and a vector is a file from a piece of CAD software like SolidWorks. The maximum laserable area on our machine is 36 inches by 24 inches. The laser power is 90 watts, which can cut just about 3/4 inch thick rubber or plastic. By comparison, your DVD burner has about 0.1 watts of power. When you use the laser cutter to engrave, you can engrave on things like wood, plastic, leather, stone, and metal if it's been painted or previously coated. You can use this for all different sorts of applications, things like making rubber stamps or printed circuit boards, or even layering plastic to make different signs or awards. If you look around the Innovation Gym, you will see lots of examples of things that have been engraved. On the other side, the more useful part and use of the 3D of the laser cutter is actually cutting. This laser, we can cut wood, plastic, rubber, paper, and cardboard, but not metal. So if you need to design and make gears or wheels for a robot, for example, the laser cutter is a very fast way to do that. Most importantly, when using the laser cutter, is safety. This laser itself, because it can cut through wood and plastic, can obviously cut your skin or even blind you. Now, the laser cutter is completely enclosed within the machine that you see to the left, and just the windows on top will actually block the infrared light from getting to your eye. So it actually is very safe. The most important one here is the fact that while you are using, fires will occur at times inside the laser, because in order to cut material, you are actually burning the material. Softer materials, or ones that are more flammable, will ignite, but most of the time they will put themselves out immediately following. Now we're going to look at the hardware of the laser to show you some of the key points. First, let's start off with the switch, which is used to turn on the laser. Below the switch, you can see the control panel, which is an indicator panel for what's going on the machine. And you'll also see the red e-stop button. If you hit this red e-stop button, the machine shuts down instantly, knowing that if you get into an emergency, that is the very easy first thing to do. To reset that panel, you just twist and pull. The laser cutter itself is mainly a 2-axis of cutting, where you only are cutting in X, Y, but the machine itself actually has automated control in both X, Y, and Z. The Z functionality on this is so that the laser can be focused and that you can cut parts that are very, very thick. You may not be able to cut all the way through them, but you can make a mark on something of any thickness itself. The machine itself uses a system called flying optics, which means that the laser tube sits behind this gray panel here and goes out the side, bounces off the mirror right here to the mirror that is already on the gantry, and then this mirror bounces to a mirror here, which then goes down to the lens in the laser head, which then focuses all of the energy down to the part. You can see an example of what's going on in the head in this image right here. The laser comes down and then converges right to the point of the laser. This lens has a 2-inch focal length, which means the surface of the material you want to laser cut needs to be 2 inches from the location of the lens. This optics create a spot that is about 5/1000ths of an inch in size. So when you cut, know that you will have a dot size of about 5/1000ths of an inch. There are other lenses available, but we typically keep this lens in the machine. It's also important to note that when you cut with a laser, you do not get a straight vertical cut. You have something that's called a taper, and it's called the kerf effect due to the laser beam itself diverging right after the point of convergence. Keep this in mind when cutting, and it will be a bigger impact on thicker materials. Some notes about the hardware. This laser itself was designed, and the laser controller was designed and made in the USA, but the laser tube and hardware itself was made in China. What this did was allow us to buy a larger, more powerful laser for a discounted price, but it also means that there are some glitchy bugs with this laser. If anything happens that you are not sure what to do, please check with the Innovation Gym Director or one of the lab assistants, and they can assist you. The laser tube itself is a consumable and will last around 10,000 hours. It's $1,400 to replace, but if you happen to be the one where the tube fails on, don't worry, that's part of the Innovation Gym's budget. Software. The software that's used for the laser is called Retina Engrave, and you launch this software by clicking the triangular icon that's down on the taskbar. This software itself has quite a few number of different features, and I will now run through some of the features and demonstrate how this works. What you may notice is that there are two different types. There's two different tabs here. One is for raster and one is for vector. Each of the settings for those two different types of cutting are held independently. Now, you may have noticed that when I launched this software, it says connected down here in the left-hand corner with an IP address. If the machine is on by the key switch and not connected, you can click this little arrow here and it will connect to the machine. The next thing to notice is down in the lower set it says not homed. Homing is when you give the laser, you tell it so it knows where its 0, 0 location is. This is extremely important and will prevent you from crashing the laser head into one of the extremes and damaging parts of the laser. If it says not homed in this corner, the first thing you must do is come up and home the laser by clicking the house icon. This will cause the laser head to move to the top right corner of the bed and will then home and calibrate itself for this laser cut. Every single time the laser gets turned off or on, whether by the key switch or the e-stop button being pressed, the laser will have to be rehomed. Now that the machine is home, we are ready to get started with a file to cut. Retina Engrave software works just like a printer. So any file which can be printed can be cut on the laser. For example, I am going to use a PDF file for this example. This is a PDF file of the Innovation Gym logo. In order to send it to the laser cutter, all I have to do is go File, Print. In my printer, I would select Full Spectrum Engineering Driver and click OK. you may see a pop-up box like this that says large raster job. This means that the file that we've imported is very, very large. If your goal is to just vector cut your file out, you can click no. If you plan to raster, you will click yes. A word of warning, if you try to raster a very large file, it will take extremely long to import. So for this case, we will just click no. You now see full spectrum laser. In the Vector Cut tab, the Innovation Gym logo has been imported. A vector itself is a file which can be easily manipulated without distortion. This file can be brought in, it can be dragged to resize, it can be rotated, it can be mirrored, it can be flipped. You can scale it by a specific value, and you can even add cross-hatching. Now, the laser itself has many different settings that you can do. The most important are which are the speed, the power, and the number of passes. The laser itself with cutting is all about net power. If you put the lowest amount of power that you can do is if you were to set the speed to 100% and the power to 1%. On the other side, if you set your speed to 1% and your power to 100%, that would be the maximum. It would also most likely catch your material on fire. In order to set the power, all you have to do is use these buttons, or you can actually click and type in the power that you need. There is a handy reference Excel sheet on the desktop of this computer which has some predefined settings for the common materials which are used in the Innovation Gym. The other important thing to note is that most of the time you do not want, if I wanted to cut all of this out, I want to cut things in groups. In order to group items, you click on their edge and you actually can change their color, which will allow you to apply different settings to different regions of the print. Where this becomes important is you want to make sure that if you are going to just engrave a part, you are not cutting all the way through while you're still trying to cut an outline. This will be obvious when I show to print. So in this scenario, I will select the outside area and the IG itself as the same color. These two item areas will be cut out while the red will just be engraved. For this example, we are going to use a piece of wood. Now, the first thing that you have to do once you put your material in there is you need to focus the head of the laser to make sure that it is 2 inches over. You use the jog the jog buttons over on the right side of the menu to actually move the laser head. If you move the laser head to an area which you want to cut, you then click the auto-focusing button here on the top and click OK to the pop-up box. This will move the layer tray until the material itself contacts the gold plunger, which is your Z focusing tool. The next step is to make sure that you have enough area to cut the item in which you want to engrave or laser. The laser itself will always start the object in the top left-hand corner where my mouse is right now. You can make sure that you have enough placement on your material by using the Run Job Perimeter tool. When you click it, this will draw the rectangle which is on the complete exterior of your part. I will click it again to show. This is a very important tool because it allows you to maximize or minimize the amount of waste as you can butt your part up to other areas of pre-cut sheets. Now that your material is focused and that you know that we have enough space, we need to make sure that the settings are correct. For this plywood to be cut, we need to go to 50% speed and 100% power, and just an engraving mark, we will leave it at 100% speed and we will drop the power to 20%. Now that we have our settings set, there are some other items you need to do before you are ready to cut. The laser itself has a number of accessories which are all controlled all at once through this remote control. The first of which is an exhaust fan, which turns on to pull the smoke from cutting and push it outside through the vent on the wall. The second of which is a water pump. The water pump pushes cold water around the laser tube in order to keep it cool. And lastly is an air pump which pushes an air stream down the same path as the laser in order to help keep a cleaner cut. Before cutting is allowed, you must take this remote control and you must turn on all of those features. You may hear some beeping and some loud noise. That's how you know that everything is on. Once you have turned all of those on, be sure to shut the door. For this example, now that you have shut the door, all you have to do is hit the green button in order to start the job. You can see an estimate of the time duration in the lower right-hand corner. The other options that you have when you are setting up your files are the order of your parts, where sometimes you might want to say, I want it to engrave first and cut second. So you can advance whichever one is has a number 1 will cut first. If you have two things that are equally number 1, it will make the decision based on most efficient cut path which one it will cut first. You also have the ability to make it run multiple passes. In the case of wood, a lot of times it makes more sense to cut more passes at less power because you will get a cleaner finish on your parts. Those settings must be modified before you start. While you are cutting, if you need to stop the machine for any reason to pause, you can actually hit the pause button, which will stop. You can hit then the pause button again, and it will resume exactly at the same spot. If you hit the red stop button, you will not be able to resume your cut. Once your cut is complete, give the machine a few seconds to clear the smoke, and then you can open the part and check your cut part. As you can see, the outside and the IG are cut all the way through, while the area that was red on the screen has just made a mark on the wood. This is an example of how to take a part that you have designed in SolidWorks and take it to the laser to be cut. This is a wheel hub which I have quickly designed. In order to export, we use a file type known as a DXF file. So what you can do is go to File, Save As, and select DXF, and click OK. It's going to ask you in SOLIDWORKS what the front face of this is. You want to make sure that you export your DXF looking straight down on the two-dimensional area which you would like to cut. The easiest way to do that is to click the Faces, Loops, and Edges button, and then click on the surface, which is the top, and then click OK. A preview box will open just showing you what you are going to export. The white lines, if it looks like what you need, then you are fine, and click Save. Now you are done with SOLIDWORKS. We open a piece of software that is on this computer called Inkscape, which is an open source free piece of software which is very powerful. In Inkscape, you go to File, Open, and then you select your DXF file. Inkscape is then going to ask you what scale you need to import it at. If you designed your part in SOLIDWORKS in inches, the scale factor is 25.4. If you designed your part in SOLIDWORKS in millimeters, the scale factor is normally 1. I'm going to click 25.4. You will see that it imported the file right here into Inkscape. There are a few things you have to do to this file in order to make it laserable. First of all, the laser will laser anything that is publicly available. Now, because our SOLIDWORKS is an educational edition, then you need to click on that text and click Delete. The next thing that you need to do is you need to set the thickness of the line by highlighting it all and right-clicking and selecting Fill and Stroke. When you're in the Fill and Stroke menu, go to Stroke Style. I normally select it down to inches, and you must set your thickness to anything less than 0.005. I normally choose 0.004, and then hit Enter. The reason for this is if your line thickness is thicker than 0.005, which is the point size of the laser software itself will interpret that you need to cut both the inside and outside of the line, making it do 2 passes. You want to avoid this as it adds to complexity and a lot of times miscut parts. The other thing that you can do in Inkscape is set the colors to help group your parts together. For example, I would like to cut all of the inside holes before I cut the perimeter. So in this scenario, I click on the perimeter and then I change its color to red. That will group all the inside holes together as they are black, and the outside will stay independently as red. Now, in Inkscape, before you go to laser, you might want to switch this to inches to make sure that it is the right size. I know that this circle is supposed to be 4 inches, which it is, and so everything is good. The next step is as simple as going as File and Print. You also select the Full Spectrum Engineering driver, and now you click Print. If you go back to our driver, you will now see that that new file has now been imported into Inkscape. You now have control of both the red and the black layer. For this cut, I would set it up as black would cut first with an order of 1, and red would cut second. The black lines are not going to be through cuts, so they'll go 100% speed and 20% power, and the red line, because it's cutting all the way through, will set at 50% speed and 100% power. Then I would follow the same process that I did on my previous cut in order to cut this part out. And that is how you bring files from SOLIDWORKS into the laser cutting software to make sure that they are dimensionally accurate. Make sure that when you are finished with your laser cut, that you go to the desktop and click the laser cutter logging file. This will open a web browser where you can log your actual laser cut. Once you are done laser cutting, you must first remove your parts from the laser cutter. Make sure that any small cutouts are also removed and thrown away. You can then go to the remote control and hit off, and then turn the key to turn the machine off. This makes sure that everything is shut down. Now, there are a few do's and don'ts about the laser cutter. Make sure that you always turn on the remote control and water flow. If the water pump is not moving water through the laser tube, the laser will fail prematurely. Make sure the exhaust fan is running as well. If you can't hear these items moving, they are not on, and the laser will not work. Also, make sure that you check for fires, and if they are, that they are put out. You may not ever leave the laser unattended when you are laser cutting. While the 3D printer, you have the ability to move on. With the laser cutter, when this laser is actively on, you must be standing there ready to hit the e-stop at a moment's notice. Do not laser any vinyl, PVC, or Sintra. These will produce toxic and corrosive gases. While we have a good ventilation system, we would prefer that you not do damage to everybody in the building's lungs. Do not try to cut metals on the laser cutter. It will not work. Try to your best not to touch the mirrors or the optics in the laser cutter, as misaligning those mirrors or optics will cause the cut quality to be very, very poor. Same thing goes for rattling the parts of the entire laser cut head. A few tips and tricks. Focusing the laser is one of the biggest things dealing with cut quality. If you feel that your cuts are extremely wide, most likely it's out of focus. This is the #1 problem for people on the laser so far. If it doesn't work or you're unsure, you can try again. It can take trial and error to get things right. If you are uncertain, please look for the Innovation Gym Director or one of the lab managers or TAs. If your part is constantly causing small flame-ups, it means that you are using too much power. Different materials all have different types of settings, and it will require figuring out the exact settings, specifically if you went and bought material on your own and brought it. Sometimes material will come with a plastic or paper protective coating on the part. Sometimes it's better to cut with this paper still on in order to get a better finish, but other times it's better to remove it before. You will have to determine which application is right for you. If you're starting and you want to cut, please use Inkscape to start or use SolidWorks, which is supported. Other software may be used for building files for the laser cutter, but these are the ones that we know the best in the Innovation Gym. If you have any problems, please feel free to contact the Innovation Gym Director or the Lab A's or the TAs of your class for assistance. You can also find plenty of information on the Full Spectrum Engineering forums.